Assalamu alaikum, welcome to your YouTube channel Structure Design Expert. Today our topic is spectrum response spectrum. So we will define the response spectrum, model cases, functions, load cases, modes of response spectrum, scale factor calculation. So RS is equal to Ig over R. So I is the importance factor, it is equal to 1, and G is the acceleration due to gravity, which is 9.8 kilonewton per meter and 386.4 kips, and R is the response amplification factor, which is 8 for C. So let's start to define. Add modify or add new, so we will modify it. So enter the model case name as a RS, and there is two, so we will select again, and the mass source is already we have selected ms1, and mode of the spectrum will be, we select 20. You can select anyone, 12, 20 or 15, no problem. So this is the advance. If you want to add advance, so if you select the SSR, so now we selected an other one is CQQ, so therefore we selected 20 modes. Okay, so now RS has been created. So now we select go to define, select the functions, response spectrum, select as C710 and modify and show. So if you want to add new, you can also select new. Here you should to enter the value of the uh, 2-second acceleration spectrum acceleration SA and 1-second acceleration S1, as you selected in the load cases there and earthquake. So from there you can select as per the ASC 17 or 716. So the RS is created. So now go to define, select load cases. So here is the, we will add the load cases. Load case name is response spectrum, and here select a response spectrum, and mass source is already selected, which is ms1. We have already selected here there. So now add new, select the RS response spectrum, which we already, and this is the G value of G gravitational, which is calculated by the Etab. If the Etab not calculated, you want to calculate it manually, so it is 9.8 kilonewton per meters and 386.4 for kips. So here is already calculated. So Ig over 8, it means that R is equal to RS is equal to Ig over 8. So I is the importance factor and G is the acceleration due to gravity, and R is the amplification factors. So Ig divided by R. R is the amplification factor, as we already discussed about the R. So multiply by 1 divided by 8, and same as that. If you selected the SRSS as a model construction method, so then you can add 30% of the acceleration u2. So here we select the same because we selected CKOC equal to, but we will select the same 1225.83. If you want to add advance, so here if you want to enter the angles, the value of angles, so you can add, but here in for this model we not to use the advance because we want to select the model construction method is CQC. So therefore modify the we use this one because the value of the damping is 0.05, so it's okay. Okay, so here you know that the value of the damping is 0.05, and we select the so already the response spectrum root case is created. My dear viewers, if you not selected our turn to subscribe to our channel, so please subscribe the channel and click on the bell icon for more updates. So we are now we run the analysis. After run the analysis, once the analysis has completed, so then we will check the value of response spectrum. So go to display, select a show table or response spectrum. So this is the signs of the damping, and damping 0.02, damping 0.03. This is the signs of the damping. So this is the damping which is 0.05. So in this side you know that this is the spectrum accelerations millimeter per second square, and the down x-axis is period of periods, so per second it is calculated by per second. So here is the calculated in the maximum, and the minimum is also shown here. You see here. Now we check the response combined story response plot. Select here, you will see that here you can see the shear and displacement as a drift as will shear in kilonewton per meter over turning kilonewton per meter. So that's all the detail for the spectrum acceleration due to gravity. You can observe from these diagrams. So now we go to the detail. Anyone, if you want to check it, the response spectrum curve, so you can check it. We already checked this one, so we have to check the go to table and mass model participation, the base response spectrums. So here is the base reactions. So right click here and show the table. So we will see the response spectrum. So the earthquake is already given. So here you can, the formula is used here as here is the if the dynamic shear more than 85% of static base shear, so no action is required. So if the dynamic base shear is less than 85, so the static base shear, then the scale factor will be adjusted such as R is matches to 85% of the static base shear's new scale factor will be should be 1g over R by 0.28. So add 2, it is we written 28, but it is add 2. I'm sorry for that. So static base shear multiplied by 8 to 0.82, it means that 0.82% static base shear. So and run the analysis, then the scale factor will be here. So now we want to calculate it here. So this is the scale response spectrum. Here is 2432.1334 divided by the earthquake. Here is 14046.445 is equal to, it will multiply by 100 is equal to 17%. So the other one is in y direction. Here is reaction in y. If y here is 1634.8184 divided by earthquake and reactions of y is 14046.445 multiplied by 100. So that both of the we should to multiply by 100 because we want to find the percentage. So it is 11%. It means that it is 89% and one is the 83%. So it's okay. In the other way, you can also check here in other table. We move to other table. Here you will see that the dynamic and static percentage. So we go to the model information from this table. So select here structure output, model informations and model information and model period and frequencies. The first is frequencies and the second is the model percentage. So we'll select the load, show the table. So here is the dynamic and static will be shown here. So this is okay, and select the dynamic and static here, a ratio of the dynamic and static reactions. So here is the ratio dynamic and static is here. So the item is 99 point static and dynamic is 97.6. So it is more than 85.9. So the table is okay. So it is we know no action is required to choose the other one. So it is okay. You can also see the time period in Rx and Ry, Rz directions, kilonewton per meter. And that's all about the response spectrum. Acceleration due to gravity and all the detail. If you want to check any details, you can check from this table. So go to table and then structure output, model information, and then you can select each and every one. So the other, this is we already discussed about this one, that you can find the percentage we already from this table, and you can also see the percentage ratios, model information ratio, model participating ratio. So from that you can also find this one. So my dear, it is requested to, if you not subscribe our channel, please subscribe the channel and watch the video to watch the video upcoming with details.